Hey, hi, hello, how are you?
Hey, hi. Hello, I'm doing well. Thank you. How are you doing?
Yeah, I'm also fine. Thanks for asking. So let's get started with the interview. Can you tell me about yourself, your technical skill set, in the project on which you worked on?
Yeah, I have 4 years of experience working in IT industry. I've been working on various technologies, starting from Java, Spring Boot, Microservices, MySQL, and one of the no relational databases. So specifically, I'm using Java version 11. So I have exposure to Java 8 features as well. And when it comes to my project, so I've been working in banking and finance domain. So there are various reconciliation projects that I've been working.
Okay. And what are your day-to-day activities?
Day-to-day activities is we manage our day-to-day activities using Jira. We work using Scrum, using Agile methodology. So generally, we have stories assigned to us, and whenever we get the stories, we also get the estimation for it. So based on the estimation, we actually go ahead and do the development. And once the development is done, we send that story for the quality assurance. And once the quality assurance is completed, we deploy that story to the production. There are basically two types of things we work on. One is enhancement and one is bug fixing. So for enhancement, we try to add new features to the application. And for bug fixing is where we try to correct some of the behavior of the application.
Okay, fine. So let's get started with Java 8 and then we will move to the Spring Boot and microservices. Okay, so I'm going to share a problem statement with you and you have to solve that problem statement. So you can see I have provided you a list of skill sets. You can copy that list and you have to write a Java 8 program to find all the skills from that list. So can you copy that list?
Okay, so I've copied it. I'm just creating a
Okay.
class Java 8 demo. Okay, and this class will also have the main method. It's going to be starting point of my application. And this is the list I can see that you copied, that you sent to me.
Yes, correct. Now, what you have to do, you have to find all the skills from all these three lists. So this is basically a list of strings. Okay, and you have to find all these skills into a single list.
Okay, all right. So I have a list of string. So I can see each element is again a list of string, right? And I need to find all their skills and add it to one list. So that is the goal, right?
Yes, correct.
Right. So the first thing I'll do, I'll take skills. And in Java 8, we generally use streams. I'll try to get stream out of it. So this will give me stream. So this is we process object one by one, and that is known as a stream. After this, what I'll do, I'll try to use flat map. The flat map is where we have multiple lists, and we try to combine all the lists into one single list. So that is where we use flat map. So to the flat map, I get skill list as one of the parameters, and I'll try to extract stream out of it. The skill list dot stream. So this is where we are giving a stream of the internal list, and that will be combined into one big list. And after this, I'll take collect, and there are convenience classes. For example, collectors is one convenience class, and I'm going to collect this to a list. So to this. And finally, what I'll get all the skills which are mentioned here, nine skills into one single list. Okay? List of string, and I'll name this as all skills. All right. Now, just to print this, I'll use this out and I'll print all skills. Here, what we have done, we have flattened a list of lists into one list. Let me run this. Okay. So as you can see, there are nine elements in this list.
Okay, perfect. Now you got all the skills. What you have to do, you have to find skills which are starting with S character.
As character. Okay. there are one and two skills which are starting with S character. For this, what I'll do, I'll take all skills dot again stream. Stream is the basis of Java 8. And for getting all the skills starting with only S, we are going to use filter because we are performing filter operation. What I'll do, I take skill and I'll do skill dot, there is a method starts with, and we have to start with R or S. So I'm going to start with S. So this will give me only the elements which are starting with S. And finally, I'll collect the result using collectors dot do list and capture the result into a list of string and skills starting with R equal to this. And same as above, I'm going to print it. Skills starting with R. Okay. There are two lists now. One is all skills and one is the skills starting with S. So skills
Okay,
starting
so
with S.
that is good. Yeah, you can just rename the variable.
Okay.
Okay, so do you know threading in Java?
Yeah, I know threading in Java.
Okay, so what are the different ways to create a thread in Java?
So there are two ways to create a thread. The first way is where we extend the thread class directly. And the second way is where we implement the runnable interface, override the run method, and we pass this instance of runnable interface to a thread class. So these are the two ways of creating threads.
No. Okay, so can you show me how to create a thread using by extending a thread class and then start that thread?
Okay, all right. So let me thread demo. Like, so this is going to be my driver class or thread. Okay, so we'll try with first one, which is extending a thread class. Let's try to create my thread. Okay, my thread extends thread. We are extending thread, but we have to override one important method, which is public void run. So this is where your execution starts. Okay, and this out starting execution of thread by extending thread class. So this is the first way. Okay. Now, in the thread demo, what I do my thread one equal to new my thread. Okay. And then what I do thread one dot start. So we never call run method directly. We just call start method. Start method will notify the scheduler that this thread is ready to run. And whenever scheduler wants it, scheduler will pick and call the run method of this thread. Let me
Okay,
run this. So starting execution of thread by extending thread class. My thread is started and it is also run. Now I'll go ahead and show you the second way. Okay, the second way is using runnable. My runnable. So here we don't have to extend the class. We have to implement runnable. Runnable is an interface and it has the same method. Public void one. And I'm going to do this out. Running thread with the runnable interface. Okay. So I've created my runnable, but this is not extending thread yet. All right. Let me go ahead and my runnable equal to new my runnable. So I got the runnable and now I'm creating a thread. So every runnable, when you want to run it, you want to pass it to the thread. So thread to equal to new thread, and as a argument, this thread accepts runnable. So I'm going to pass my runnable And now I'm going to do thread2 dot start. So this will start my thread. Let's go ahead and run it to see if it works. Okay, so you see the first one is using thread, and the second one is using runnable.
Okay. Can you tell me when we should go for runnable and when we should go for thread?
So ideally, I generally go for runnable. I generally don't go for thread because consider this: if you are extending the behavior of thread class into your class, then only go for extending thread. But consider there are a few classes where I don't want to extend the behavior of thread and I just want to run this functionality in threads. Then I go for runnable. So whenever you want to extend the behavior of thread class, then only use extend. Otherwise, don't use extends. And whenever you want to provide a thread, then go for runnable interfaces.
Okay. And how comfortable you are with the design patterns?
I worked on design patterns. I worked on singleton. I worked on adapter,
Okay.
factory, abstract factory.
So what is the difference between this factory and abstract factory design pattern?
Okay, so factory and abstract factory both are both come into the category of creational design patterns. Creational design pattern means we are trying to create complex objects. So let's try to go ahead with the factory design pattern first. Factory design pattern is where given an input, the factory method knows which kind of object to create. For example, there are three types of objects. For example, payment using UPI, payment using Bitcoin, payment using credit card, and I pass a variable to the factory method, then it will give me the appropriate object for doing the associated kind of payment. Okay, so this is a factory method design pattern. And abstract factory is where we are creating objects which can work with each other. For example, let me try to find an example. Okay, so you might have seen themes. Okay, so there are two types of themes. One is dark theme and one is light theme. So for light theme, you render dark components, and for dark theme, you render light components. Okay, so if you render a dark component on a dark theme, then that component might not be clearly visible. But these are kind of associated objects. So for example, when I have dark theme, then the other method should always give me the component for that dark theme. So that is the abstract factory, where you give the objects which are compatible with each other. So that is abstract factory.
Okay, great. Let's move to the Spring Boot. So let us consider I have to perform a CRUD operation using Spring Boot. So can you tell me what will be your strategy? What will be your annotations and endpoints which will be used in your application?
Okay, all right. So I'm going to write comments here itself. So I want to design a CRUD. So CRUD basically means create, read, update, and delete. So these are the four major operations that we perform in case of designing the application. So the first thing that I am going to do is create a controller. Okay, and this is going to be my REST controller because I'm going to use REST APIs. In a Spring Boot world, we can use different standards, but the most widely used standard is REST, which is representational state transfer. Okay, so I'll annotate my class with @REST controller. So this is going to be my REST controller. What does this mean? This means that I'm going to write various methods into my REST controller, which are going to handle various types of requests. Okay, so there are various types of requests. Get request is there, post request is there, put request is there, and delete request is there. The get is where I'm trying to get some data from the server. Post is where I'm trying to post something to the server. Put is where I'm trying to update something on the server. Delete is where I'm going to delete the data from the server. Okay. Now, the next thing I'm going to do is write methods and annotate it with the annotations, either get, post, put, and delete. Okay. After that, from my controller, the call will go to the service, and from service, the call will go to the repository. And repository is where I'm going to do the interaction with my database. Okay. Now, there's one more important thing. which is kind of a status codes. We generally, after making a request to the server does some operation, and based on if the operation is successful or if the operation fails, we are going to send back the status codes. So there are few status codes that we have used in our application. Whenever the operation is successful and we assure that we created the resource or we performed the said thing in the request, then we send back 200, which is okay. Okay, all right. And sometimes we don't find the resources. So in that case, we send back 404. Sometimes there is internal server error, and in that case, we send back 500. And sometimes there are too many requests to our server. And in that case, we send back 429. So this is what we are going to do while creating REST APIs.
Okay, so what will be status code when you will try to delete a resource from the server?
Okay, so when we try to delete a resource, generally we send back 201, which is where the operation that you are asking for is successful, but we are not sending back any data to the client. So that is no content. But in our application, we are catering to 200.
Okay, so is it 201 or 204 for no content?
I think it's 204 for no content. 201 is for created with content.
Okay, good. Now, can you tell me what were the annotations which you are going to use for service and repository layer as well? You have mentioned a direct REST controller that will be for controller, right? And what will be for service and a repository layer annotation?
Right. So there's a generic annotation known as component, which we can use anywhere. And when we want to create a service, we want to we use @ service, and for repositories, we use @ repository. So this signifies that my service class is a service being, my repository class is a kind of doing repository related stuff.
Okay, and what will happen if I exchange this annotation? So I will write a direct repository on service class and a direct service on a repository class. Will your code work?
Yeah, the application will work as it is because these are known as stereotype annotations, but these are more kind of indicative annotations. So if I add service to my repository or repository to my service, even in that case, things will work because both of them are component and kind of indicative annotations.
Okay, perfect. And you have experience working on microservices architecture as well, right?
Yeah, so I've been working on microservices architecture.
Okay. So can you tell me the architecture of your project?
Okay. So the architecture of my project is we have several microservices, 7, 8 microservices, which are being managed by different teams. So microservices is where you divide your application into multiple services which are small enough and which solve problems related to one business area of your application. So consider you have one big application where there are 5 different functionalities. So based on the business needs, you can divide this application into 5 different microservices, and each microservices will be developed, and the responsibility of that microservice will lie with only one team. So now let's go to the components of microservices. So generally, what happens? The first thing in any microservice application, the entry point is known as API gateway. So this is where all the requests that come from the client will always go to the API gateway first, and then API gateway in turn will decide this request will be forwarded to which of the microservices. So API gateway will interact with microservices in the backend. So it can either go to microservices 1 or it can go to microservices 2. Now, how this decision is made? Consider this. I am trying to make a request, HTTPS, and for example, capgemini.com/. Okay. Now, I'm trying to apply for the interview. Consider this apply. Now, any request with related to application is handled by microservices 1. Okay. Now, API gateway knows any request that is starting with /apply will go to microservices 1. So this request will be sent back sent to the microservices one will be processed and the result will be replied back. So now let's do one more thing. HTTPS slash capgemini.com slash PGV. PGV is background verification, and any request related to PGV will go to microservices 2, will be processed in microservices 2, and will be replied back. So this is how the API gateway decides to which microservice your request will go. Now, once a request is in the microservices world, basically, sometimes it happens that one of the microservices needs data from the other microservice. So consider this, for example, microservice one needs the data of microservice two. In this case, what we do, we try to identify where my microservice two is running. For this case, we are trying to use something called as service discovery. So it is evident with the name that we are trying to discover another service. For example, microservice one wants to get the address of microservice two, then we are going to use service discovery. Okay. For service discovery, we are using Eureka. Right. But there is a prerequisite for service discovery. Whenever we have the service starts, in that case, that service has to register itself with the service discovery. For example, microservice one will register with service discovery. Microservices two will also register with service discovery. Now, whenever microservice one wants address of microservice two, then it will go to service discovery, ask for the address, and then make a call to microservice two. Okay. Now the last part in the communication. So if you want to communicate with microservice two, there are two approaches. One is known as a synchronous approach, and one is known as a sync approach. So in synchronous approach, both the parties have to be present at the same time. So for example, microservice one wants to call microservice two, and the communication is synchronous. Then both of them have to be up at the same time. Because in synchronous, we do the request and we wait for the reply. Okay. But in case of asynchronous, we make the request and we don't wait for the reply, and we assume that the other service is going to process my request and going to perform the operation. So this is how we design our microservices.
Okay. And how do you handle the loads of these microservices?
Load
Load. So how do you manage the load balancing?
Load balancing. Okay. So generally there are two types of load balancing approaches that we take. One is client-side load balancing, and one is server-side load balancing. We are using client-side load balancing, and there are various ways to balance this load between clients. So what does client-side load balancing mean? Is consider this scenario where microservice one is calling microservice two, but in this case we have multiple instances of microservice two. Consider this is my first instance of microservice two, and then we have one more instance of microservice two. Okay, because the load of microservice two is very high. That is the reason we are deploying it twice. Right. Now, what will happen in case of client-side load balancing? When microservice one wants to call microservice two, then microservice one will get both the address of both the microservices. Okay, it will get, for example, one is working on IP address x.y dot z.a, and the port is 8080, and the second is working on m.n.o.p, and port is 8080. So it will get address of both the microservices, and now microservice one is free to decide whether to call this microservice or this microservice. And the load is being balanced by microservice one, who is the client of microservice two. That is the reason it is known as client-side load balancing, and we are doing this with load balances annotation, which is applied on the bean of REST template. And there's one more library. Sometimes in some of the microservices we use ribbon. So these are the two things we are using for client-side load balancing.
Okay, great. And do you know any? How do you handle the failures of your microservices?
Okay. For failure in the sense, some of the microservices are down.
Yes.
Okay.
So let us consider your microservice 1 wants to communicate with microservice 2, but microservice 2 is down. So in that case, what will be your response to client?
There are various approaches to handle this. So we handle this using circuit breaker. Circuit breaker is where consider I want to buy something. There is my buyer microservice, and the buyer microservice in turn calls a payment microservice. Okay, because while buying we need to do payment. Okay, and my payment microservice is down. Now, what will happen if the request comes to the buyer microservice and buyer microservice calls to the payment microservice just to understand that it's down, then it will try multiple times. But if this retry is done multiple times, then there is a problem that I am bothering payment microservice, which is still struggling to cope up with the number of requests that is happening. There's a concept known as circuit breaker, where what we do, if there are some number of calls, for example, if there are 3 calls which have failed from buyer microservice to payment microservice, then I never call payment microservice until some threshold is reached. For example, after 3 failed calls, I'll wait for 10 minutes, then only I'll give call to my payment microservice. So I'll break the circuit in between for next 10 minutes. And after 10 minutes, if there is any request that comes, then I'll try one more time if the payment service is able to serve my request. If it is not able to serve my request, I'll again break the circuit for 10 minutes. And I'll keep on doing this until my payment service is fully recovered and able to serve the request.
Okay, great. So I'm done from my side. Do you have any question for me?
No, I'm also done for my side. Thanks a lot for your time. Thank you.
Yeah, thank you. Bye.
Bye.